these are your 4-2 solving quadratic equation notes. We are going to discuss several different ways. The rest of this chapter almost is, the majority of it is methods to solve quadratic equations. So we have to kind of define that here. This is the first method. It's not my favorite, but the first way that we're going to solve quadratic equations is by graphing them and then interpreting the graph. So really quick, just to go over some terminology. A quadratic equation is an equation of a quadratic function. So you're taking the function that was y equals or f of x equals, and then we set it to a number instead of the y value. So we actually give the y value, we replace it with a value itself, a numeric value. So a function is what you graph, has a y and an x. An equation is something you solve, and the majority of the time when we solve these, we get it set equal to 0. Because when y is equal to 0, that's a significant number. If your y value is equal to 0, that means that we're only looking at where the graph crosses the x-axis. If your y value is 0, it didn't go up any, it didn't go down any. We're looking for the point or points where it crosses the x-axis. So a couple different ways that people talk about this. I'm going to kind of walk you through it. So that first bulleted point, if y is equal to 0, this represents the x-intercepts of the graph. That's what I was just saying. If you're not going to go up any, you're not going to go down any, it's the x-intercepts of the graph. The x-intercepts, we sometimes refer to them as the zeros of the function. And the reason we call them the zeros of the function is because we plugged in 0 for y. It's when y is equal to 0. The solutions to the equation are referred to as the roots of the equation. So it's asking us to solve. So we're finding the solutions. The solutions, roots, zeros, x-intercepts are all basically saying the same thing. One method for finding the solutions is to find its zeros by graphing. So I just want you to understand that right now, until we get into more detail, but right now we're just going to kind of use these terms interchangeably. So, and this is going to carry through beyond quadratics when we study other type of functions. So if we talk about the x-intercepts, that's the same thing as a zero, a root, or a solution. So just know that all of those can be kind of interchanged. But what we're really looking for is where does the graph cross the x-axis when they ask you to solve. So we have 3 different scenarios, 3 different things can occur when you graph a parabola and you graph a quadratic, and you can have 3 different solutions. So if you graph the parabola, and let's say that the quadratic, the vertex lands on the x-axis, then this particular model, this quadratic, would have one real solution. And the one real solution is where it crosses the x-axis. So in this case, it looks like it's like 2 to the left. So our solution here would be -2. And we just put it in solution sets like we did with absolute value functions. In the second scenario, we have a graph where it's going across the x-axis twice. So it's hitting in 2 spots. So this has 2 real solutions. And the 2 real solutions are where it crosses the x-axis. So let's just pretend or say that it's crossing at +2 and -2. I don't really know the values, I'm just estimating. The third case here, you can see that the parabola does not touch the x-axis at all. And so therefore, this situation would be no real solutions. There are no solutions. So today, what you can have as your answer, you could have no solution, 1 solution, or 2 solutions. And I just want to mention that this is true for parabolas that open upside down as well. So if the graph is opening downwards, right, we could actually have where you're opening down and there's no solution. You're opening down and there's 2 solutions, or you're opening down and the vertex is on it, so 1 solution. So this is true for all, whether they're opening up or down. That really doesn't matter. The orientation doesn't matter. So How we're going to solve these today, we're going to graph them, and then we're going to interpret the graph. So the graph is your work. The graph is your justification and your proof. So you're going to graph the related function. You're going to identify the zeros, and then you can always check your solutions by plugging them back into the equation and seeing if they truly do equal 0. Now the difference here, okay, this is a little confusing. They're going to give you something that looks like this. And what we're going to do is change it, get rid of the 0. So we're going to go back to what we had before when we were graphing. So we're solving, but in order to solve, we got to change that 0 back to a y value. So it's kind of confusing that way. Let's go ahead and give it a shot. So in this particular case, I can see that there's a 0 here. Okay, well, we're going to replace that with a y value. And then I'm just going to change the order in which this is written in. So all I did there was rewrite it so that the y was on the left-hand side. I think we do better that way. So y equals x squared minus 3x minus 4. Remember from the previous assignments, when we graph, we got to find negative b over 2a. That is your vertex. I don't really need the axis of symmetry today. If you want to find it, that's fine. I am going to use my y-intercept, though, as one of my points. So x equals negative b over 2a means a positive 3 over 2 times 1, which is a positive 3 halves, which is 1.5. So my vertex is 1.5 something. To find the something, I have to plug that value into the equation. So y equals 1.5 squared minus 3 times 1.5 minus 4. When I figure that out with my calculator, I'm going to square the 1.5. And when you square 1.5, you get 2.25. And when you multiply a negative 3 times 1.5, you get a negative 4.5. And then you subtract 4. So in the end, when we take 2.5 and subtract 4.5, and then subtract another 4, you get negative 6. And so, did I do that right? I feel like I did something wrong there. I did do something wrong there. 1.5 squared is negative is 2.25 squared. So when I actually do that math, 2.25, take away 4.5 minus 4, there we go, negative 6.25. Sorry about that. So this graph is going to cross at 1.5 and negative 6.25. That's our vertex. So I'm going to go over 1.5 and then down 6 1/4, just below 6 there. I am going to use my y-intercept. My y-intercept, remember, is staring at us, so no calculations necessary. It's just the ordered pair 0, negative 4. Remember, it's your c value. So 0, negative 4 is to the left of my vertex. So I'm going to put 0, negative 4 here. And that's 1.5 units to the left. So 1.5 units to the right would be 3, negative 4. So I have 2 ordered pairs there that match up. Now I just need a couple more to finish my graph. I can tell you right now that there's going to be 2 solutions. I can see that from my graph. My vertex is below the x-axis. I'm opening up. There's going to be 2 solutions. I just don't know what they are now. So I'm going to go ahead and pick negative 1 and 4. I'm going to go out more. I really don't need to pick points in between the vertex and those other 2 points. So I can either plug in negative 1 or I can plug in 4. I'm going to use negative 1. So when I plug in negative 1, I square it. I use parentheses. Minus 3 times negative 1 minus 4. Negative 1 squared is 1. A negative 3 times a negative 1 is a positive 3 minus 4. Y is equal to 0. So negative 1 gives me 0 and 4 gives me 0. And actually, those are my solutions. So I can finish my graph. And not only do we finish our graph, we can see that there's 2 solutions. I can see that the 2 solutions are at negative 1 and positive 4. So I write them as solutions. The graph is not the answer. The graph is your work that supports your answer. I drew you a picture of my solutions. So that's kind of why I like this method. It gives you a good visual of what's going on. So our answer for this problem is -1, 4, and your work is the graph that supports it. Let's try another one. So in this case, we got to do some rearranging first. If we're trying to figure out where it crosses the x-axis, that is when y is equal to 0. So I'm going to add 4 to both sides to get it equal to 0. So I get x squared minus 4x plus 4 is equal to 0. Now that I have it equal to 0, I'm going to replace 0 with the y value. And actually, I probably could have done this at the same time. I'm going to rewrite it so it's y equals x squared minus 4x plus 4. So now that I have it in the right order, I'm going to find my x equals negative b over 2a. So to find my vertex, x is equal to, an opposite of -4 is +4. 2 times 1, that's 2. So my vertex is 2 something. To find the something, I got to plug 2 into the function. So y equals 2 squared minus 4 times 2 plus 4. Get in the habit of using parentheses. That's 4 minus 8 plus 4. If I'm going too fast, you can always pause it. And y is equal to 0. 4 take away 8 is -4. -4 plus 4 is 0. So actually, I already have when y is equal to 0. X is 2. So there's my vertex. My vertex is actually on the x-axis. So I know now, I don't care if this opens up or if it opens down. It actually opens up because my a value is positive. I know I'm going to have one solution. I already have the solution, but I still need the graph to show me the results, that this is a quadratic and this is how it works, that it only crosses one time. So we continue the problem. My y-intercept is 4. So if my y-intercept is the ordered pair 0, 4, when I plot that, I can see that's to the left of my vertex. So 0, 4, I'm going to put that as my last point because I already have my answer. So I don't need to go so far out beyond 0. You do that, you get bigger numbers. So I've got 0, 4, that's 2 units away to the left. So 4, 4 would be the matching point, 2 units to the right. And then I'm just going to pick the ordered pairs in between, like 1 and 3. So I'm going to figure out when x is 1 and when x is 3. These two match up. They're symmetrical. So I don't have to plug in both. I just got to plug in 1. I'm going to use 1. Y equals 1 squared minus 4 times 1 plus 4. Be careful of your signs and your parentheses. That's 1 minus 4 plus 4. And so that's equal to 1. So we got ordered pair 1, 1, and 3, 1. Got enough information to connect and extend. And then I can clearly see that my solution, I have one solution this time, and it is 2. If you were to plug 2 into the original problem, we always plug our answers into the original to check. If I plug in 2 and square it, I get 4. When I plug in 2 and take it times it by 4, I get -8. 4 minus 8 is truly -4, so it checks. All right, we got another graph here. This one's all set up for us. The only thing we have to do here is replace the 0 with a y and rewrite it. So I feel like we can do that all at once. Y equals x squared minus 4x plus 5. X equals -b over 2a. That's a +4 over 2 times 1. That's 4 over 2, or 2. So my vertex, again, is 2 something. To find the something, I have to plug that in. So y equals 2 squared minus 4 times 2 plus 5. That is 4 minus 8 plus 5. And that's 1. So my vertex is 2, 1. And I can tell by using just thinking about it a little bit, my vertex is above. My a value here is a +1. And so it's going to rise. So this parabola is going to open upward. I'm above the x-axis. I already know that it's no solution. You kind of know how many solutions there are as soon as you place that vertex and the sign of your a value. But we still have to continue graphing because that's how we're solving. My y-intercept is 5. And so 0, 5 is one of my ordered pairs. It's to the left again. So I'm going to go 0, 5. That is 3 units away. And so if 0, 5 is 3 units to the left, I'm going to go 5, 5 for 3 units to the right. It matches up. Oh, I'm sorry, 2 units. So after I graphed that, I realized that I was off. So I need to fix that. That's going to be 4, 5. We were only 2 units away. Did not look symmetrical. I'm going to plug in 1 and 3 again as my other point. I'm going to use 1 again, so I'm going to square 1 minus 4 times 1 plus 5. That means y is equal to 1 minus 4 plus 5, and y is equal to 2. So 3, 2, and 1, 2 are my other 2 points. Connect and extend. You got a nice picture. You got a nice visual that there are no solutions here because it never crosses the x-axis. So again, the answer, the solution, what your answer is no solution, but all of that other beautiful work in the red and the green there in the graph support that answer. That is the proof. That's worth more to me than the actual correct answer. Now, there's times where that when you're solving, they don't really cross at a nice spot. So sometimes they're going to give you a picture, or you're going to get a picture and you can't really say exactly where it pinpoints. So then we just have to estimate. So in 4, if you notice, the solutions are here and here, but they're not a nice little grid mark, little crosshairs. And so we're just going to say that there's 2 solutions. There's 2 solutions here, and the 2 solutions are between 0 and 1, and also between 5 and 6. So what that tells me is that the solution is 0 point something and 5 point something. We just don't know what it is. So this is one of the downfalls of using graphing to solve. It's not very accurate. It gives a great visual of what's occurring. It helps you see the solutions, but if it's not exact, it's not the best method. In number 5, you could plot these points, but what you're going to see is that the first point, looking at the y values, okay, the f of x values, these are your y values. My y value here is positive. So that means I was up above the x-axis. So I'm above the x-axis. But the next value is negative, 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 negative. So these are all below the x-axis. And then the last one is positive again, so we jumped back up. So where you switch signs, when you go from a positive to a negative y value, there's a 0 that occurs in between there. We crossed the x-axis here. And the same thing happened here. We crossed back over down here. And so where that occurred on the x-axis is between 0 and 1 and between 5 and 6. So this table is actually the table that belongs to that graph. So I just wanted you to see it both in the graphic form and in the table format. You look at the y values to determine where did a sign change occur. And so when I went from a positive y value to a negative y value, then I look at the x values, and that's where the solution occurs. Number 6, we're going to save for class. We'll do that one together as a little warm-up. And so what I need you guys to do now is I need to just sketch a picture of a quadratic equation that has one solution, and then also I want you to determine the solutions based on that graph. Okay, so really no work tonight, just some interpretation. Good luck.